And hello, everyone. Welcome, people who are joining us for the first time, as well as returning students and teachers alike. My name, of course, is Francis Terrazio. I'm a weather observer, meteorologist, and education specialist up here on the summit of Mount Washington. Today's topic we're going to be focusing on includes Earth's climate system and climate change. Before I begin, I just want to remind everyone that we're doing pre-recorded virtual classrooms. We're uploading it onto our website, mountwashington.org/classroom. And then every Tuesday morning at 11:15 a.m. Eastern time, you can either join us through Zoom or Facebook Live, of course, and you can send questions about the previous week's lesson to our Observer Live, and we'll try to the best of our ability to answer any and all questions you have for us. So Tuesdays again, 11:15 a.m. Eastern time, our live Q&A. So without further ado, I'd like to get into today's lesson. So I think first a really important distinction and difference I want to remind everyone about is the difference between weather and climate. Weather can be just described as, well, if you want to make this a metaphor about the types of clothes we choose for weather, weather is the daily outfit you have. So today, here on the summit, of course, I'm wearing a big jacket when I go outside. I've got goggles, hats, and gloves. But, you know, a little earlier this afternoon, it was a little bit warmer. So I didn't have the goggles on. I didn't need to wear a hat necessarily. And so weather is going to be that day-to-day change. You know, maybe one day you're wearing your rain jacket or a sweater, and the next day you're wearing your flip-flops. Beautiful sunny day. So weather is that daily change, that hourly change in atmospheric conditions. Whereas climate, you can think of climate as longer-term weather, averaged over a period of time, typically 30 years. And so that's best to be thought of as, well, what's in your closet? You know, what season are you in? Are you wearing? Is your closet full of primarily short sleeve shorts during this time of the year, or maybe you're packed up with long sleeve jackets, hats, and gloves and things like that because it's the winter months. So just a quick little reminder there about the difference between weather and climate. I want to also talk about what a system is, and a system is essentially parts, individual parts working together as an interconnected network, a larger thing. And so you can think of something like a machine. Of course, you've got hundreds of gears making that machine work. Something like a car's transmission, for example. Well, our climate system's similar to a machine you may be more familiar with. There's different parts to it, different components, and each of these components do work together. And so there are about 5 major components of the climate system. The atmosphere, where the air and the gaseous part of our Earth is. The hydrosphere, the aqueous or water-based part of our Earth, both liquid and solid. Speaking of solid, the cryosphere talks about ice, glaciers, sea ice, things like that. We have the geosphere, the shape of the land, topography, and then finally the biosphere. And that consists of all living things. All of these components work together to create a larger system of weather and climate on the planet. First one, atmosphere. They're the gases that surround the planet. This is the most unstable and they're rapidly changing. And the compositions have changed with the evolution of the Earth. So what the atmosphere is actually made up of, that ratio between oxygen and nitrogen, for example, has shifted throughout our planet's history and is constantly doing so. The hydrosphere, this is all of Earth's water. We're talking about surface water, subterranean water, so water that's under the ground, as well as fresh water. Very important for us as human beings and living beings, but most of the water on Earth is saline. It's from the ocean. So all of these systems, all these different types of water, I should say, are quite important. The cryosphere, this is frozen water. These are our ice sheets, our glaciers, and our sea ice. A large portion of our drinkable water on the planet is actually encased in ice. And ice also does affect the energy balance. So ice will tend to reflect solar radiation back out into space because it is a very obviously white and light material. So the solar rays bounce right back. And so the cryosphere is very important for regulating global temperature, for regulating our weather patterns. Geosphere, this is everything that makes up the crust and core of the Earth. Anything to do with land surface, mountains, how they affect climate. We talked in a few lessons, or 2 lessons ago, I should say, how mountain meteorology is hard because you have rising and sinking air on either side of the mountain, and just the features, the surface features that make up Earth's geography to play a really major role in our Earth's climate system. And finally, the biosphere, all living components of Earth. These include humans, plants, animals, fungi, and bacteria. These living creatures exchange gases with the atmosphere, and these gases can affect the temperature profile of the Earth, things of that nature. So how do these spheres influence climate? Well, they interact with one another and they influence the bigger picture, and everything is indeed connected in the climate system. A really good example are trees. Trees uptake water, obviously from the soil, and then through evapotranspiration, they release that water through the leaves. And so it's just a small example as to how something like the biosphere does affect the whole Earth's climate system. So I want to now start to transition. We're going to start to talk about climate change, and we'll start with this slide here. Long-term climate or changes in climate that occur over decades, centuries, or longer. So now we're talking about scale of 10, 30, 40, 50 plus years. And this is a deviation from the usual weather, what the averages, things we may expect. And changes can be found in things such as temperature, rainfall, drought, and extreme weather. And so instances of those phenomena change. We look for changes in temperature, getting warmer or colder. And so we have observed a warming of the Earth. And so typically the temperature of the Earth is largely governed by what's called the greenhouse effect. Of course, there's lots of other components to the Earth's climate system, but this is one of the most important. And so the energy comes from the sun, and some of it does go back out into space. In fact, the majority of the energy that arrives from the sun does get deflected back out into space, but some of it is held on to by what were called greenhouse gases. And these greenhouse gases are actually way more efficient at absorbing that solar radiation than, say, other types of gases. And so Earth is around 60 degrees or so on average, but without the atmosphere, without these greenhouse gases, well, things wouldn't be as hospitable. And so in the last 100 years or so, we've noticed significant changes in these greenhouse gases. And so I've got a few graphs here. We'll take one at a time here. I know there's quite a bit going on. I want to first bring your attention to carbon dioxide, one of the most common greenhouse gases. And you can see a steady rising trend since about the mid-1900s, rising up, starting off a little under 350 parts per million. That is just a unit of measure of how many parts of carbon dioxide per million parts of other gases there are in the atmosphere. Another really powerful greenhouse gas, which is really good at trapping heat, is methane. Methane, we've also observed an increase. And nitrous oxide, similar story there, a sharp increase, especially in the last 20 or so years. So every one of these greenhouse gases are rising, and I want to talk a little bit about why this is the case. These changes are largely driven by human activities, the act of burning coal, oil, natural gas. These allow for the increase in greenhouse gases into the atmosphere, especially the emissions. And there's a lot of other activities that help to increase greenhouse gases. These include farming, deforestation, and land development. So the carbon dioxide is no longer able to be sequestered or pulled from the atmosphere by that biosphere. So those trees that absorb carbon dioxide and give us our oxygen. Well, if you remove those in favor of a highway or an area of farmland, well, of course, that land is not going to uptake as much carbon dioxide as greenhouse gases. And so those levels in the atmosphere are going to increase. And so the changes in greenhouse gases are not just limited to the changes in those gases. Of course, I mentioned how the greenhouse gases have a warming effect on the planet. And we have observed since the mid-1900s a pretty impressive warming trend. Here, this red line is showing warming trends of just the land surfaces themselves. And we're running a little over or near 1.5 degrees Celsius above what was considered pre-industrial before we started actually burning coal and natural gas and oil on a large scale. And so you can see warming across not only the lands, but the Arctic especially is warming quite rapidly, as well as the oceans. And so we're going to talk a little bit about now how this warming is changing the different spheres, the different components of our Earth's climate system. Changes to the hydrosphere with melting glaciers, with the warming of the world, and the shrinking cryosphere. We mentioned all the ice that's locked up on land and glaciers. Well, we're seeing an increase in ocean water heights. So we've seen about an increase of 102.5 millimeters since 1993. It doesn't seem like a whole lot, but over the scale of the entire Earth, that is a really remarkable change. And that change is actually starting to accelerate. So here we are now with a higher sea level than what we saw back in the early 90s. And so pretty incredible changes going on in the oceans. I also want to point out changes to the cryosphere now. we see a significant loss in land ice in both Antarctica and Greenland, and this, of course, is contributing to those sea levels rising that I did mention before. So we're going to let these graphs play out. You can see a really steady decline, especially in the last few years. Notice Greenland, and here we are in 2022. Antarctica, similar story there. It's a large scale decreases. This is a map showing the sea ice thickness in meters. And what you need to know here, these brighter colors are the thicker, older sea ice, and these lighter colors are, or should I say, darker blues are younger, or is younger, thinner sea ice. And so you're going to notice the area of older, thicker sea ice has actually been decreasing over the last few decades. So we'll start back in 1985. You can see that concentration and extent decreasing, shrinking, especially over the last, again, 20 or so years. And so some big takeaways we can take away from our presentation today. Earth does have 5 major components to the climate system. Each component interacts and depends on the interactions of other components. So here's an image showing how these different systems, they're all interconnected, you know. And so the components, again, with the atmosphere, the hydrosphere, cryosphere, and finally the biosphere. And some big takeaways from climate change. Changes to climate include changes in temperature, precipitation, occurrences of fire weather, occurrences of extreme weather, of course. And these changes that we've seen have been largely driven by increases of greenhouse gas concentrations. And those increases in concentrations can be explained by the burning of fossil fuels, particularly since the early 1900s. This is translated to a lot of different types of changes to the Earth's climate systems. These changes are resulting in increasing temperatures, decreasing sea ice, decreasing glaciers, the land ice we mentioned, sea level rise, and then of course further increases of greenhouse gases. And so I want to wrap up today's lesson. Of course, you can always register for our virtual Q&A. I know there's going to be a lot of questions about climate change and the climate systems going forward. So please join us. You can also look at past lessons at mountwashington.org/classroom. You can submit your questions when you're registering for our Q&A through Zoom, or you can send them to my personal email, fterasmus@mountwashington.org, or education@mountwashington.org. And I'd like to thank everyone for joining me today, and have a great day.